Okay, so I'm live here with 52 weeks of AWS. And in particular, what I'm going to cover is continue to go through the solutions architect material. Last week, I covered the compute layer. And this week, I'm going to cover the database layer. And I'm also going to talk to you about a course I just finished and I pushed it up to O'Reilly, the AWS Solutions Architect Professional. So the elite version of the Solutions Architect exam. And in fact, let me just show you that exam material here because I worked pretty hard on it. So if you go to here, here we go. So basically, if you go over to O'Reilly, this is the only place it's at currently. It will, I believe, be on LinkedIn Learning as well pretty soon. But basically, if you were looking for an AWS Solutions Architect Professional course, well, you're in luck. I have one. You can see here I've gone through and I have all of the stuff for domain one, and I'll have all the stuff for domain two, domain three, domain four, domain five. So pretty comprehensive. And the other good news is that it's only about 2.5 hours or so as well. So it's a nice little refresher for people that are looking to take the AWS Solutions Architect Professional course. So take a look at that if you get a chance. So I'm going to move on though to the AWS Solutions Architect, just regular, and I'm going to go back to the layer module 5 here, which is a database layer. And I'm going to talk about that today. And so to start with, adding a database is a great thing to know how to do inside of the AWS cloud. And so we're going to start off with, what is a database as part of a larger architecture? What it really means is that you're going to, use it in a cloud native way if you're using it on AWS, probably using things like Aurora / RDS. And, I think some of the considerations to consider for a database is scalability. Can you actually make this thing handle the traffic you send to it? What are the total storage requirements? What are the size of the objects and different things that you're putting inside, and then the durability? These are all important considerations, and it's hopefully something you do before you even spin it up. When you are already in the middle of a deployment, or been working on a product for 9 months, and then you have to re-architect things, that's a lot more difficult. But it's hopefully something you can do a little bit of pre-planning before you launch. So in terms of storage requirements, a few things to be aware of are, how much data do you actually need? It's going to be gigabytes, terabytes, or petabytes. If it's petabytes of data, I think a relational database may not be your best bet. You may want to look at a different solution like object storage and do more of like a data lake type solution. Object size is another one. You don't want to put like huge movie files into a relational database. Again, that would be something for Amazon S3, or if you have huge like satellite images or something like that. These are all things to consider. So another thing to consider is what level of data durability, data availability are you looking at? So are there regulatory obligations? These are all important considerations for building out your database. There's a couple different styles for a database. The traditional one is relational database, MySQL, Oracle database, Microsoft SQL Server. Non-relational, there's MongoDB, Cassandra, Redis. These are all really important considerations. Now, with a relational database, some of the things to consider are that there is ease of use with a relational database. There's just a tremendous amount of prior knowledge, tools. Also, there is transactions and data integrity because you have the ability to create schemas. There's reduced data storage, and there's the SQL language, right? A lot of people have familiarity with the SQL language, so it's a great place for you to start with, potentially, if it fits your problem. Also, relational is ideal if you have to do data quality enforcement. You have strict schema, so you kind of know exactly what it is you're building. You don't have extreme read write capacity, and you don't have extreme performance. In that particular scenario, it's the best, lowest effort solution. But there are many situations, especially for startups, where they realize that a non-relational database is a much better move. And the reason for this is that it can offer flexibility, scalability, high performance, high functional APIs, right? If it's a key value based model, if you're only storing like game data or something like that, then a key value model could really be the way to go. And also, if you know you need to scale horizontally, why not? Why not just go for the horizontal scaling capabilities? Another thing to consider is if it doesn't lend itself to a traditional schema, like if you're constantly changing your schema all the time because you have a very strange kind of data set, that could be an issue. And then read write rates exceed what can normally go through a relational database. So a graph would be a great example. So if you do need a relational database, though, there are some options on AWS. You have RDS, which has been around for quite some time. And then there's Amazon Redshift and Amazon Aurora. For non-relational databases, you have on Amazon DynamoDB, Amazon Elasticache, and then Amazon Neptune. These are all non-relational databases. DynamoDB is key value. Elasticache is a cache-based system, and then Neptune is a graph database. Okay, let's get into RDS a little bit. What is it? Well, it's a fully managed relational database service. You don't have to do a lot of things. They're done for you. And so one of the ways to think about this would be in the case of host databases on-prem, you have to manage just a ton of stuff, including the power and the networking. In EC2, you have to manage a lot less, right? You don't need a data center, but you still have to manage patching and all that kind of stuff and scaling. But with RDS, you just focus on the app. And so it really is a tremendous benefit for you if you're building something quickly. Here's some of the characteristics of RDS. The access pattern is transactional with light analytics. The data size is low terabyte range. The performance is mid to high throughput. Low latency. Business use cases would be, transactional or OLAP. Amazon RDS uses and database types. It works really well for things that have more complex data, need to combine and join data sets. You need to enforce rules. There are 6 databases supported: Microsoft SQL Server, Oracle, MySQL, Postgres, Aurora, MariaDB. So this is actually a very interesting thing to consider here is that, for example, SQL Server is a great tool for a .NET developer because it's got some special, hooks in there. And in fact, there is Babelfish, which allows you to use the same style, but even talk to Aurora Postgres. Okay, instance sizing. What are some of the things to consider? Well, we've got the T family, the M family, and the R family. What are these differences? So T family is basically an economy, right? It would be burstable, anywhere from 1 CPU to 8 CPU, moderate performance for RAM. It's really for like just maybe, kind of toying around a little bit. The M family is for high performance RAM. It's ideal for CPU intensive workloads. You could have up to 96 CPUs and 384 gigs of RAM. So this would be definitely a very, very performant database that potentially is under a lot of load. And then you have the R family, which is for query intensive, high connection count. So you could have 96 virtual CPUs and then almost a terabyte of RAM. So, 768 gigabytes. So what are some things you would do with RDS? You could have, some users put some data somewhere, they do a data transformation, and you put some of the data into a data store. So with RDS, why don't I just show you how this works here? Let's go to the console, and I'm going to just spin up a machine real quick, log in, And it's actually pretty straightforward to launch an RDS server. So what I'm going to do is I'm going to auth into my account, and then I'm going to go ahead and just look for RDS. So here we go. RDS, you can see here, manage relational database service. What's pretty awesome about RDS is that you can just click a button and it spins up a database for you. And so if you see here, there's a default window right here, like it says, here we go, create database. I click on create database, and it gives me some options, right? It says, what kind of database do you want to create? You want to use the standard creation method where I would control every single feature of it, or do I want to use easy create? I think probably if you're just getting started, easy create is a good way to go. And then the next thing to pick is engine type. Do you want to pick Amazon Aurora, MySQL, MariaDB, Postgres, Oracle, MySQL Server? And then if you do pick Aurora, which is probably a good bet to start with, you have the choice of Amazon Aurora MySQL compatible or Amazon Aurora Postgres compatible. And then you also have, in this easy startup here, easy create, you have the idea of either a production or a dev test environment. I think if you're just kind of kicking the tires, dev is probably the way to go. And then you just leave everything default. It'll auto generate a password for you. And then you just go ahead and say create database. So really a trivial process to create a database using RDS. And then you can later use whatever tool you like to use. Like, for example, in this case, we're using Postgres. So, a Postgres connection manager, connect to it, do some SQL queries, or some other, commercial tool that talks to a database and allows you to do SQL queries. You also could go through here and select the query editor, and that could work with serverless databases. You could also take a look at things like automated backups and, look at all that kind of stuff. There's a lot of really great features that come with this. Okay, so we created that thing. Let's go to the next thing that's important to point out about RDS is that in most cases, if it's a production environment, you want to do multi-AZ. And the reason for doing multi-AZ is that just in case there's some kind of an issue, like, for example, you wanted to deploy this to, let's say a company that's either a startup or a profitable company, Fortune 500 company. You want to have multiple availability zones where the synchronization between the primary and secondary is occurring, because of the fact that if there is a problem in a region, then it can automatically transfer to that secondary database. So this is really nice because it's got enhanced durability, increased availability, loss of availability in primary availability zone. All this stuff is really kind of baked in there for you, and it does come with the RDS system. It's just a switch that you toggle. So read replicas are great for performance because they allow you to send some of the read traffic to the read replicas. It's increased availability. It's designed for security. It's also supports MySQL, MariaDB, Postgres, and Oracle. There is a limit, though, of 5 read replicas per primary. And then for strict read write after consistency, you would read from the primary. Now, RDS, this is probably one of the best parts of RDS, is that you have the ability to do snapshots automatically. You just click a button and automatically backs up your database. The classic problem in a company is that you don't have your database backed up. I've had it happen to me in real companies before where you lose data, and it's really not a good situation. There's no excuse for this with RDS. If you use some kind of exotic database, well, anything can happen. But with RDS, you just click automatic snapshotting and it goes through and it creates these snapshots. So really amazing feature. And then you can restore from that snapshot. So Amazon Aurora is worth pointing out that it is a fully managed MySQL and Postgres compatible relational database used for online transactional processing, or OLTP. It's got better performance than traditional MySQL. It's 3 times better performance and throughput than Postgres. And you can also have data 6 ways across 3 availability zones. So really like a more robust uh, distributed computing scenario for Aurora, and it doesn't require really any changes. Amazon Redshift is a data warehouse solution, and you would use this for online analytics processing. So the idea here would be, if you're going to have a very large data set, like for example, maybe historical stock price data over every single minute for 10 years, or you have some millions and millions of rows and you want to do counts on those, that would be a great example because it's a columnar based database. So some of the takeaways would be: manage AWS databases, handle a lot of the admin tasks. The RDS system supports MySQL, Oracle, MySQL, Postgres, Aurora, and MariaDB. Multi-AZ is the way to go for automatic failover. You can have 5 read replicas for RDS. Aurora, you can have even more. And it actually lets you go across 3 availability zones. And it's got capabilities to work with MySQL and Postgres. And then Redshift is what you would use for data warehousing. Okay, let's get into Dynamo now. So Dynamo is pretty cool because it's a fully managed key value database, and it allows you to have performance at any scale, extreme horizontal scaling. It's serverless, event-driven, enterprise-ready. So like really a pretty cool service to just start building stuff. Some of the things that it works well for are high volume data. If you want to scale quickly, you just want to start building solutions immediately, I would say DynamoDB is amazing for this. It allows you to have really high throughput, low latency. You don't have to do any kind of schema. There's in-memory caching. You can have peaks of 20 million requests per second, which is just bonkers, right? Like, I mean, that 20 million requests per second, I can't even imagine what kind of a system would need that, but you can get it. So here's an overview of DynamoDB. It's got data partitioned by the partition key here. Data elements are stored as attributes. A table is a collection of data elements. An item is a collection of attributes. And then there's sort ranges. So really, you can think of it as like a fancy dictionary or a key value store. Also, DynamoDB has global tables. So you can actually have replicas in the different regions of AWS, and there's fast local read-write performance for global applications. The global tables provide a multi-region, multi-master database. One of the use cases for DynamoDB is for doing things like leaders and scoring. So you'd have players, game servers, leaderboards. So I think like a game-based system where you're keeping track of scores would be the classic thing you'd want to do with DynamoDB. Like, you don't need a relational database for this. You just want to have basically a user ID, the name of the game, what their score is, and when they scored it. Something like that is perfect for DynamoDB. Another one would be temporary data, right? So somebody's looking at your e-commerce system and they got some shopping cart data and you want to store it somewhere. That would be a perfect use case for it. Some of the things you can do is you can have both eventually consistent and strongly consistent. And this strongly consistent, if you're familiar with the CAP theorem, it means that there's a trade-off, right, between consistency, availability, and partitionability. And so you need to do something to change one of those attributes. You don't get them all. And so you can make DynamoDB have strong consistency. And this would require all reads to return a result that reflects all writes before the read. So you could do a trade-off if you needed to. Let's take a look at DynamoDB here. So let me just spin it up real quick so people can see a copy of this. I'm going to go to my console, go to DynamoDB, and Dynamo is really easy to start off with. And in fact, all you got to do is go to tables over here, click on tables, say create table. And then for this, we would just say table name. We just say like, hello world. And then really the only difficult choice you have to make, which is a pretty simple choice, is you have to create a partition key. And so the partition key is a hash value. So basically, what is it you're going to look up the results from? Just like a dictionary, right, in Python, where you want to have the unique value to look things up. I'm going to type in UID, right, unique ID, and then I'm just going to leave everything to default. And by default, it'll have some level of auto scaling setup, and it really will be able to set this up in just seconds. There we go. Here's our hello world. We're good to go. Now, if I want to go through and I want to, create something inside, I think I can just go here, go to actions, create item right here. So you go to create item, and we could just put something inside. We can say Apple, right? There's my value. And then I could create another one, right? I could just make whatever I want inside of here. And we can say cherry, right? Add some fruit in here. And then how do I query this? Fortunately, very easy to query. One way to query it is to scan it. So if I go through here, I can, in fact, I can look at metrics, but I also can go to, where is this scanning section here? It's escaping me. Monitor, explore table items. There we go. Explore table items. And you can either query, like you could just type in, a value, or you can do scan and you can just say run, and it just gives you back all of the UIDs. So you can think of it almost like Google Sheets in a way, like it's kind of at that level. But what's nice about it is it has the ability to let you query it from another language. So if I wanted to, click on this button here, for example, and open up Cloud Shell and then play around with Boto 3 and then import, the Boto 3 API for DynamoDB. It would be, pretty easy. In fact, I guess I could try that real quick. Let's go ahead and do this, Boto 3, and see if we can find DynamoDB inside of here and see if I can query it. That might be kind of fun. Let's go to Dynamo here. Here we go, DynamoDB. I can just find an example of Dynamo. There we go. Here's a client's. So if I want to do this, let's see if we can play around with this. Clients. Here we go. So I've got Cloud Shell environment should wake up here in a second, and once it fully wakes up, then I'm going to do a pip install, and then I'm going to pip install both IPython and I'll pip install Boto 3. I like to do IPython when I use Boto 3, so I can just do an interactive, experiment. Go through here and let's try this out. Looks like it's still warming up here. Should be here any second. Cloud Shell. Yeah, usually Cloud Shell, for some reason, I'm not sure why it takes sometimes a few minutes to wake up. It's almost like I should use Cloud9. I like Cloud Shell though, because you just click the button over here, but sometimes it can take a little bit of time. I can also make it larger, change the theme, light to dark. There's a few little configs I can do here, but okay, here we go. I'm in my environment. I'm going to say Python 3-m venv, and I'm going to create a virtual environment. I'm going to source it, and then I'm going to install IPython and Boto 3. That's all I need to do. There we go, venv, and activate. Pip install IPython, and then I'm going to say pip install Boto 3. Perfect. So very, very simple. I go to IPython and I just do those commands that I see inside of the reference documentation. I say import Boto 3. So this is where you see the value of using something like DynamoDB, is that there's nothing to do, where a relational database, there's a lot of steps to kind of get data out. In this case, if I just want to scan the database right here, I just say scan. I believe I can just do something like this. I can say response equals client scan, and then just table name, something like this. Let's see if this works. Let's paste this in. Response is equal to client table name, and we'll call the table name, I think, was hello world. Let's go back to this and look at our DynamoDB database. Is right here, and it is table was called hello world. Perfect. And I'll change in. Basically, I'm doing import Boto 3, client equals Boto 3.client, and then I'm pasting in a response to client.scan, the name of the database inside response. There we go. Pretty easy. It shows that there's two values, and it even showed me what the values are. So it's trivial in Python, just four lines of code to pull data out of DynamoDB. So that's really, I guess, the other thing here is that I don't have to scale it. I don't have to do anything. It's totally managed, totally backed up, and I can just use basically Python and talk to it, or whatever language I want to use to. So that's really the advantage, I think, of DynamoDB. Okay, what about database security controls? Pretty easy. You can run RDS instance in VPC. That would be a best practice, right? Like, you never want to expose your database to the outside world. That would be a very bad practice. You would want like a web application that went through maybe a load balancer, and that web application would privately, talk to your relational database. You could use IAM policies for auth, security groups, SSL, maybe encrypt your data as well. All those are great ideas. So what about DynamoDB? Same thing. You would use IAM roles, IAM policies, make sure that VPC endpoints are protecting it, make sure you're using encryption. Okay, what about migrating data into AWS databases? This is a little bit of a subtle issue, but there are a lot of amazing tools on AWS that you can use to sync the data into a database. So here's one of them. I've used this before, actually. It's called AWS Database Migration Service. I think the day it came out, I played with it 2013 or 14. You can use it to migrate to and from commercial and open source databases. And so you would take your source database, maybe it's Oracle, you set up a job, and then you convert the tables into the schema of an Amazon RDS database for Oracle. You could also do MySQL, and you could convert it to Amazon Aurora. So you can both do homogeneous and you can do heterogeneous, right? You can go database to database or database to a different kind of database. So some of the features is one-time migration, or you can do continuous data replication. A lot of times the one-time migration is too good to be true. What happens is you have a legacy application, people are still using it, and you're trying to figure out a way to get the data out. And so you need to do some kind of replication. Now, there also is schema conversion tools as well. So you would create a database, migrate the schema, set up the data replication process, initiate the transfer, and then switch production to the new database. So that's typically what I would do, is I would kind of get the thing syncing for a while, make sure everything looks good, then you just, flip the switch, and then you go to the new database. There also is AWS Snowball Edge with AWS DMS. This would be a scenario where, let's say, your database migration is just too big. It's too much, the connection is slow, or there's privacy security concerns. You could actually export it to Snowball Edge, put it in a truck, right, and then move it over to AWS. I would say, if we just scroll through here, maybe the wrap up here would be that basically the things that we went over was how to compare different types, when you want to use RDS, when you want to use DynamoDB, and how do you migrate data into a database. So that's a pretty good handle for what I wanted to cover this week. So next week, I'll go to, let's see, we're going to be covering next week creating a networking environment, and we'll get into some networking on AWS. But thank you for attending 52 weeks of AWS Solutions Architect version. And one other thing to watch out for is that I believe on Friday, I'm going to be interviewing some O'Reilly authors for a GPT book. And we're going to talk about natural language processing and all kinds of stuff. So go ahead and take a look at that upcoming 52 weeks of AWS podcast as well. But otherwise, I will see you next week at 4 p.m. All right. Talk to you later.